Hello and welcome to T1 Day 5 of Honors Precalculus. Today we're going to continue with analyzing functions. Specifically, we're going to be looking at intercepts. So if we take a look at this first function g of x right here in the green, like with any function, if you want to find the y-intercept, you're examining when x equals 0. The y-intercept occurs when x equals 0. And remember, intercepts, I want them expressed as points. So if x is 0, we're looking for a y value. So all you're doing right now is plugging in 0 for x, in which case you get negative 0 minus 3 underneath the radical, plus 5. Just make sure you're careful with that negative sign, so you end up with negative 4 times the square root of 3 plus 5. So that's the output, that's the y value. So in this case, the y-intercept is 0, comma, negative 4 root 3 plus 5. And I want you to write intercepts like this, and this is the exact form. So if you want the x-intercept, that's when y is equal to 0. So you're setting the output equal to 0. So it's going to be 0 equals negative 4 times the square root of negative x minus 3, the opposite of that, plus 5. Now you just need to be careful to do this in the right order. We're going to subtract 5 first, leaving everything on the right-hand side that's left, and then divide by negative 4. So you end up with 5/4 equals the square root of negative, the square of this right here, negative x, minus 3. To get rid of a square root, we need to square both sides. So we end up with 25, because that's 5 squared over 16, and that's going to be equal to negative x minus 3. Again, you just need to be careful with that negative sign. I would then distribute it. I'll go up here, end up with 25 over 16 is equal to negative x plus 3. So end up with 25 over 16 minus 3 is equal to negative x. So x is actually equal to 3 minus 25 over 16. You're not done, because you can combine fractions there. That's x equals, turn 3 into 16, so you get 48 over, yeah, that's right, sorry. 48 over 16 minus 25 over 16 is equal to 23 over 16. So in this case, the x-intercept is 23 over 16, comma, 0. I really like it written like this in improper fraction form. I like improper fraction form. I don't like 1 and 7 over 16. I like it written like this. So here are our two intercepts. Now keep in mind, you can have at most one intercept with y-intercept with a function. You can actually have up to an infinite number of x-intercepts. In this case, there is only one x-intercept. So let's go on to the next example here. Remember, if we're talking about the y-intercept, we're looking at when x is equal to 0. The y-intercept occurs when x is equal to 0. So we end up with negative 3 times 2 to the 0 minus 1 plus 5 equals the y-intercept. The y-intercept in this case, so negative 3, 2 to the negative 1 plus 5 equals the y-intercept. Be really careful here. 2 to the negative 1 is 1 over 2, so that's negative 3 over 2 plus 5 is going to be equal to the y-intercept. So turn that 5 into halves, so you get negative 3 over 2 plus 10 over 2 is equal to 7 over 2. So in this case, the y-intercept is 0, comma, 7 over 2. Again, I like improper fractions like that. It's fantastic. So now we have a little bit more fun, and we look for the x-intercept. The x-intercept is going to be when y is equal to 0. So we set this whole thing equal to 0, and we carefully, and I like the parentheses there, just like the problem, set it equal to 0. So subtract 5 and divide by negative 3, you end up with 5 over 3 is equal to 2x to the negative 1, 2 to the x minus 1. Now you need to turn this into log form. This is exponential form. You need to turn this into log form. This log form is writing the same exact thing, but it's log base 2 of 5 over 3 equals x minus 1. And the way you convert between the two is 2 to this power equals that. 2 to the x minus 1 is equal to 5 over 3. These are the same. It's exponential form, and you're converting it to log form. So then you end up with log base 2 of 5/3 plus 1 equals x. And you can leave it like that. That's totally fine. You can rewrite this. It's totally fine. You can rewrite it a little bit differently, but I like leaving it like that. That's totally fine. So that tells us the point is log base 2 of 5/3 plus 1 comma 0. That right there is the intercept we were looking for. Now let's look at this rational function and try to find our intercepts. It's really important to first see if there are any removable discontinuities. And the way you do that is by factoring the numerator and denominator and seeing if anything cancels. Now you'll notice that you can pull out a -2 from the top. So if you pull out a -2 from the top, you do with x squared plus x minus 12. So you end up with -2 times x plus 4 times x minus 3 in the numerator. This is the numerator. That's the numerator right there. And that whole thing is going to be over factoring the denominator, 5 times x squared minus 4. That's 5 times x plus 2 times x minus 2. That's the denominator. So what do you end up with? You end up with the simplified form being this over 5 times x plus 2 times x minus 2. This is the factored form. Can you cancel anything? Do you have any of the same terms on the top and bottom? You do not, so there are no removable discontinuities. So for the y-intercept, remember, that's when x is equal to 0. Remember, there can be at most one y-intercept. So you end up with, remember, it's going to be, what do we call this function? G. So g of 0 is -2, 0 plus 4, 0 minus 3, over 5 times 0 plus 2, 0 minus 2. Just be careful you simplify it properly. -2, -3, over, what was that, 5 times 2 times -2. Now, we have an infinite amount of space, really, so I'm going to call you on this, so I'll hold myself to the same standard. Just space it out a little bit so it doesn't look like one big mess here. So things cancel. Just be real careful here. And with -12 over 10, which is equal to -5 over, -6 over 5. So our y-intercept in this case is, we plugged in 0 for x and the output was -6 over 5. There can only be one. So now we set the whole thing equal to 0. To find the x-intercept, we need the whole thing equal to 0. I'll change colors here. The x-intercept is when y is equal to 0. So we have 0 is equal to this whole big fraction right here. The only way to make a fraction equal to 0 is for the numerator to equal 0. The numerator is right there. The only way for a fraction to equal 0 is the numerator to equal 0. So all we need to do is look at this. And it's already factored, which is super helpful because it can tell us what makes this 0. Well, when this is 0 or when this is 0. So either x plus 4 is equal to 0 or x minus 3 is equal to 0. So x is equal to -4 or x is equal to 3. So there are two x-intercepts in this case, -4, 0 and 3, 0, which is totally fine because you can have as many x-intercepts as you want. It is possible to have many, 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 many. So now let's look at this log function. And this is where you get to remember how to use logs. And we might have to review this, but let's try this out. Remember, y-intercepts are when x is equal to 0. So h of 0 is equal to -3 log of -0 plus 5 plus 4, which is just -3 log of 5 plus 4. You don't simplify that. There's nothing you can do to that. So in this case, the y-intercept is 0, -3 log 5 plus 4. Yes, you can plug that into your calculator and get a number, but if I want an exact answer, this is the exact answer. Now, if we want the x-intercept of this, remember, for the x-intercept, that's when y is equal to 0. That's the output. So 0 is equal to -3 log -x plus 5 plus 4. Subtract 4 and divide by -3. So you have 4 over 3 equals log of -x plus 5. The base, when it's not written in, is 10. So in this case, this is the log form. We need the exponential form. It's going to be 10 to the 4/3 is equal to -x plus 5. There's that 10 right there. It goes in a circle. 10 to this power is equal to this. So what do we end up with? Well, again, I want this to be spaced out. So I'm going to just highlight it and just move it down a little bit. If I can actually click on it, let's find out. Oh, there we go. So how do we solve for x? Well, we just subtract 5 and then divide by -1. So we end up with negative x is equal to 10 to the 4/3 minus 5. So x is equal to, multiply everything by -1, and you end up with 5 minus 10 to the 4/3. So if we want the exact answer, it's going to be 5 minus 10 to the 4/3, comma, 0. Yes, you can get a decimal answer, but this, again, is the exact answer. This right here is the exact answer. So let's completely analyze this wonderful f of x function. And you're going to be able to use your calculator to analyze something like this, because it's not a quadratic or a linear function. You will be able to use a calculator. So if you graph this function, you end up with this really cool function that looks like this. Curves down and goes up, but it kind of goes like this, and then it goes up and then down again. Now to analyze this function, it's going to be really important because you're really looking for highest and lowest points. So you're going to want to use the min and max feature on your calculator to find the points A and B, because you'll need them. So if you do that with your calculator, it looks like point A comes out to be -1 comma -0.5, and B comes out to be 1 comma 0.5. So what's the domain of this function? Well, it looks like it covers everything. There are no holes or jumps or infinite discontinuities. So in this case, the domain is all real numbers, which can also be written as -infinity, infinity. Now what about the range? Well, the range, it never gets above or below certain values. So it never gets above 0.5, and it never gets below -0.5. So in this case, the range is -0.5 to 0.5. Where is it increasing and where is it decreasing? Well, it's going to be increasing from A to B, and you write these as an interval. So that's from A to B. What are the x values there? So it's going to be from -1 to 1. And where is it decreasing? Well, it's decreasing there and there. Remember, you're reading from left to right. So it's decreasing -infinity all the way to that x value at A, which is -1, union 1 infinity. What about discontinuities? Well, there are none. There's no jumps. There's no vertical asymptote. So you've got no discontinuities. You can draw the whole thing without picking up your pen. Is it bounded? Well, it's bounded because it's bounded above by y equals 1/2. That's this line right here. And it's bounded below by y equals -1/2. Below by y equals -1/2. You can't go anywhere above 1/2 or below -1/2. That's -1/2. I'll try to make that a little clearer for you. -1/2, like that. What about extrema? Well, extrema are relative mins and maxes, and it looks like A is going to be a relative minimum. So A is a relative minimum. A is relative minimum. And I already put the points in. It's totally okay to just write the points in up here, as long as it's clearly labeled. And then B is a relative max. They're relative mins and maxes because around them, when you zoom in around them, you can't go anywhere below A and you can't go anywhere above B. Symmetry. What about symmetry? Well, you plug in -x and see what happens. So what happens when we do f of -x? Well, that's going to be -x over 1 plus -x squared. That's -x over 1 plus x squared, because -x times -x is x squared. So that's -x over 1 plus x squared. This is f of x. That is f of x. So when we plug in -x, we end up with -f of x. Therefore, this is an odd function. It's point symmetry around the origin. What about end behaviors? What happens as x gets really, really big? So the limit as x goes to infinity, well, look what happens there. If you zoom in here, as x gets really, really big, what does the red function do? Well, it gets closer to 0. Looking at the other direction, what happens? You go in the left direction, it also goes to 0, just from the other side. So in this case, both end behaviors, the limit as x goes to infinity is equal to, not infinity, 0. And the limit as x goes to -infinity is also 0. Just as a bonus, you could say it's going from the 0 from the top, from the positive direction, and 0 from the negative direction. What about asymptotes? When you look at this picture, are there any asymptotes? Is there anything it's approaching? Well, it's approaching that blue line, which is a horizontal asymptote, y equals 0. Horizontal asymptote. There are no vertical asymptotes. There's no infinite discontinuities. So you would say the asymptotes for this one, there's just one, a horizontal asymptote at y equals 0. Are there any intercepts? Well, let's take a look. Is there anywhere where this function crosses the x or y axis? Well, there's only one intercept, which is the one y-intercept, which you can only have one of, and one x-intercept. It's the same point. In this case, the intercept where it crosses the axis, either axis, there's only one, is 0, 0. Now let's take a look at concavity, and I'll draw the graph down here again so we can take a look at it and analyze it further. So you have to look at this and look at where is it smiling up? Where does it look like it's smiling up? Well, it looks like right about like from here to here is where it's concave up. And also from like here to here, because this is where it looks like it's concave down. And then it also looks like it's concave down here. So it looks like things are changing in slightly different places. It looks like things are changing concavity here. We'll call this point C, and we'll call this point D. Remember, concave up is smiling face, and concave down is frowny face. So you have to estimate those points. You could use your calculator, and point D has an x value of about, it looks like if you use your calculator, point D, it's going to be about 2.3. So it looks like it's like an x value of 2.3 right here. So that looks like x equals 2.3. And this one right here has an x value of about negative 2.3 again, about negative 2.3. And then here it looks like it changes concavity at the origin, actually, at the origin. So concave down in this case is the purple. So concave down is going to be negative infinity to negative 2.3 union, and then what's the next purple? 0 to 2.3. And then concave up is the green. Concave up is the green. That looks like it's going to be about negative 2.3 to 0, and then union 2.3 infinity. Again, though, the key to doing this whole problem right here, the key to doing this whole problem is using your calculator to graph this function, find a and b, which you can use min and max for, and then for the points of inflection, actually that's what the name of C and D are, where it changes concavity, zooming in really far and making a good estimate. One decimal place is okay for now. We'll learn more exact methods later. So when you're just given a graph, you're just going to have to sight estimate it to find places where it's concave up and where it's concave down. So where does it look like it's concave up? Where is it smiling up? Well, it looks like it's smiling up. I'll use the same colors here. Whereas concave up was green. Okay, so where is it smiling up? Looks like it's smiling up from like here to here. And it's going down like that, there, and there. So concave down is the purple. That's going to be negative infinity to about, let's say, negative 4 right there. That's what that x value is, all the way to negative 4. Union, we'll say, oh, it's not 4. Oh, it's not to 4, is it? Oh, look at that. It didn't go far enough. So it's not actually changing concavity at the highest point. It's changing concavity where? It's changing concavity right here at this point. We'll call that point A. We'll call that point B. That looks like it's negative 2. So it's not negative 4. It is negative 2. And then where does it go back to concave down? This second purple, that's 2 to infinity. And then for concave up in the green, that's just going to be from negative 2 to 2. Wherever it's not concave up, it's concave down. Now, what about the concavity at these points? We're going to say it's not concave up or concave down at the points of inflection, which is what those are called. And we need actual calculus to do that, which you'll learn later.